Okay, so in this video I'm just going to go over using the ultrasonic sensor. Now if you watched the video where I went over using the color sensor, you'd have noticed that I did it a little bit differently. So here I actually have the code done and ready just because it's a little bit easier. I'm just going to go through the code rather than doing it, coding it out live. So basically what you'll notice is that I actually have two files open. So one of these is like an ultrasonic class that I created, and then the other one is like a main file where I'm pulling from that class. So we're going to look at this class first. I'll make it a little bit bigger so you can see that it's still part of the same package. They're both in the same package, but this is an ultrasonic class. It doesn't have this public static void main argument in it. It doesn't have this function that's actually going to run. It's just a class. It has its function for creating the class and setting it up, and then it has this function as well for calculating distance. So the way that this works is you might notice it's a little strange up here. It says public class ultrasonic, and then it says extends abstract filter. So what this means is when you use extends is like, it means that this is a subclass. So ultrasonic is a subclass of abstract filter. So the abstract filter class, I could actually pull it up here. So I imported it. An abstract filter, if I click on this class, I can open up this library. It's a class that somebody else made, and it has in it certain functions and variables that I can use when using sensors. So you'll see that they have a sample provider as one of their variables, and they have sample size as another variable. And they have this function here. So this is when they create their version of an abstract filter. When they create the class, this is what you call is abstract filter, and this function requires a sample provider. And then it sets the source and it sets the sample size, and then I can use any variables or functions that are in here in my own program. Basically, in my own program, I create an array, which is where I'm going to store data that I get back from my ultrasonic sensor. And this is me setting up the actual ultrasonic class, and it requires a sample provider to do this. So I'll actually create the version of this class will be created over in this program, but for now we'll just look at this. So this is some new syntax. We see super, and then in brackets source, which is the variable from up here. So basically what this is I'm just calling a function that's in abstract filter. Sorry, my audio cut out. I'm just going to continue my explanation. So I was looking at this super syntax here. So super refers to the parent class. So remember, ultrasonic is a subclass of abstract filter. So if I want to use a function or a variable from abstract filter, I can use super, which is just a reference to abstract filter. So super is abstract filter, which is an abstract filter has its own function, abstract filter, and then in brackets it needs a sample provider, which is what I'm going to send it. So I'm going to set up the abstract filter by calling its instantiating function by writing super and then in brackets source. And when you actually write this line, you'll actually be forced to create this little bit. It will just auto-generate all of this. So the only thing I added to this function is the sample equals new float sample size. So basically, I defined or I created the sample array up here, and then I actually defined the size of this array on this line, and the size of the array is sample size, which is a variable that I am pulling from abstract filter, which has been defined inside of this function, which is a function that I just called when I wrote super brackets source. If that makes any sense at all. Next we have this public float distance. So this is just a function that I created. So we've set up the sample provider. This abstract filter class pretty much did everything for us in a sense. So it's created all the functionality. The ultrasonic sensor is ready to go. So I'm going to use this distance function to actually fetch a sample. So I'll use super, which is again referring to the abstract filter. Super.fetch sample. As we've seen before, so fetch sample takes in two parameters. One is the location that the sample should be stored in, which is this float array, and 0, which is the index that I want to start storing values at. So I want to start storing values at the first index in this array, which is 0. And then this function, so the syntax for this function is public float distance. So you'll notice I didn't write public void distance. This isn't just a function that does something, it's a function that must return a value of type float. So I actually return the first index in the sample array, which is a float. So when this file calls this function returns sample 0 to this file, if that makes any sense. So we're going to look at the other file now. So we actually have the public static void main function, which is going to run our code. So nothing automatically runs over here at all. This is what's running. So we create this port variable, which is the port that we're going to plug our sensor into, which is sensor port 1. So we use brickfinder.getLocal to get our local brick that we're connected to, and then we use .getPort S1 for sensor port 1. And then we create an ultrasonic sensor. So we write EV3 Ultrasonic Sensor, US is what I'm going to name it, US for ultrasonic sensor, which is equal to new EV3 ultrasonic sensor at S1, which is our sensor port 1 that we just defined up here. Then we have ultrasonic ultra. So this is us creating a version of this class as an object. So that's the difference between classes and objects. This is our definition of what the object is, and that definition is called a class. An object is us creating a version of this class. So we have created an object and we're calling it ultra, and it is of the class ultrasonic that we defined over here. So we create a version of the ultra class by writing new ultrasonic, which is a new version of this class. And when we want to make a version of this class, we have to provide a sample provider. So our sample provider is the ultrasonic sensor, which is going to provide the samples because the ultrasonic sensor is what's actually outputting data. And we want to use the distance mode. I don't know what other modes exist, but we're using ultrasonic.getModeDistance. So we have set up this class as an object, and we've called this object ultra. Now we're going to use a while loop, and it will be while button.escape.isUp. So that means while the escape button is up, which means I haven't pressed it, it will loop and loop and loop until eventually I press the button and the program terminates. And this loop will reoccur every 250 milliseconds, which is every quarter second, because I have inserted a delay into this loop of 250 milliseconds. So this is float distance. So this is a float value that we're going to store in a variable called distance. And to get the distance between the ultrasonic sensor and an object in front of the sensor, we're going to call the distance function from this class. So we're going to use ultra, which is the object, which is a version of this class, ultra.distance. And that will return sample 0, which is our float value that's been stored in this sample array. So it will return that value, and that value will be stored in distance, in dist, that's what I called it. And then we write system.out.println dist, which will just print the distance between the ultrasonic sensor and an object. And then it will continuously print the distance between any object in front of it and the sensor every quarter second until we press the escape button, at which time we will then close off the sensor port, which is our sensor port 1. So again, good practice, always close off any ports, whether they're sensor ports or motor ports. When you're finished with them, close them off. So we write us.close, and then our program terminates, and that's it. I hope that's helpful. I hope that makes sense, and I hope that that helps give you a better idea of how to use the ultrasonic sensors, how to use classes, and I would recommend, if you really want to understand this, try playing around with it. Try using this class-based system. You might remember I did this color sensor, and I didn't use a class-based system so much as I just did it all in one file. Try doing something like that. The best way to get a good grasp of using any kind of technology, whether it's Lego Mindstorms or Arduino or whatever, just play around with it. It's the best way to figure it out. So I hope that helps.